All right. I think we'll get started. I don't know how many people are going to be in here and versus online. Um, but this is EMU at IETF 113 here in Vienna and online. Um, Next slide, Mohit. You all should be familiar with the note well, kind of a code of conduct for the IETF. Talks a little bit about IPR and keeping things professional here in the meeting with our discussions. And thanks, Jan, for offering to take notes. And if somebody else, you can easily get to the notes through the Etherpad link on the, or the CodeEMD link on the agenda. And if you can take notes while Jan is presenting, that would be wonderful. Thank you. Next slide. Okay. So there are around the room little QR codes that you should scan. So that that's the method for signing in with your blue sheets. So please scan the QR code so that your attendance will be recorded. That's something you agreed to do when you signed in. And for people who are online, that's already taken care of. All right, so let's go to the next slide. Just a quick overview of our agenda, which is packed today. We have a couple of working group draft items. So we'll have Yari talk first about EAP, aka PFS. Then Alan will talk about the EAP types. And then we have some other drafts that we will go into. Some of them we're going to see if there's some desire to kind of take them on as working group items in this meeting. And if we don't get enough information from this meeting, we'll have to take that to the list. The adoption call would be taken to the list anyway. Does anybody have anything to add to this agenda? We don't really have time to add anything. But, all right, next slide, please. All right, let's go to Yari's slides.
All right. Hi, guys. My name is Jari Arkko, and together with a couple of my colleagues and many contributors from the working group, we've been doing this forward secrecy or perfect forward secrecy draft, an extension of EAP, aka. Next slide. And what is the status of that? It's been sort of hanging around, I guess, partially at least due to lack of cycles on the author's part, my part in particular, but also some final details we were sort of trying to nail down. Not much, but a little bit. We'll talk about that in a bit. And waiting for, clear opportunity to put this into real world use. But I at least am a little tired of waiting. So I think it's better that we make this an RFC and nail those final details, and then it's ready to be used. And I think it's important, of course, the forward secrecy property is important for security. Next slide. So we submitted the new version 06, has a couple of changes, not much, at least not substantially much. We updated some of the references because they've been made RFCs recently. Okay, no biggie. There's also a discussion in IETF in the SAG group about the use of PFS terminology, and they came to the conclusion that one should use forward secrecy instead. And so we're trying to comply with the conclusion of that discussion. There's a link on the slide to mail that John sent to the list, I think. So we made that change, and so that's sort of editorially fairly big change because it shows up on many places in the document. We changed the name. Next slide. There's not much open issues that I know of. I think it's pretty straightforward. There's one issue, however, that has been having some discussion on the mailing list, and some people discussing occasionally at least, and my interpretation of the discussion was that it did not result in a conclusion that I could easily implement in the draft. So I asked the working to take a look at this, in particular the people who were participating in this, John and Renee and Mohit, you as well, and maybe others. So the question is about the encoding of the public value and how long it is and so on. And you can look up the discussion on the mailing list archive, but from my perspective, I need some input from the working group or from the guys. I'm not the expert on this encoding, so I'm kind of looking to others. Maybe Mohit, for instance, you can say something, but basically on the right side of the slide, you can see the actual text that we have right now. Let's talk about two curves and how they are encoded. And then there's some discussion between John and Renee, for instance, on whether it should be 32 or 33 and what the implications are. So that's the open issue. I don't know if people have thoughts now or.
So I think John is in the queue. And in theory, you should join the mic queue through your mobile app. But so John, go ahead, and then Dan.
Yep. So I'm fine with this 33. I mostly had comments about the reasons and some of the motivations behind the change and some of the statements regarding 32 byte values. Otherwise, I find this 33 byte encoding perfectly fine. I don't have anything against that. So I think we can more or less close this issue. If there's anything to do, I think then it's small non-technical clarifications in the draft or something. 3D people already use this 33 byte code compression in Suki, for example. So I don't have any. I'm fine with the current 33 byte. Yeah.
So just to clarify, I don't think we have much of the background rationale in the draft. It's been on the mailing list, maybe in the change notes, but not in the actual draft. So you're happy with the text as it is in the 06?
I can check that, but I'm fine with the technical solution to use this 33 byte encoding. Yeah. Let's look through that section together later offline, maybe. Yeah.
Dan?
Dan Harkins. So the only reason you'd need the extra byte is if you care about the sign of the point. But if your shared secret is just the x coordinate of the Diffie-Hellman shared secret point, and you throw away the y coordinate, you don't care about the sign anyway. So you don't need the extra byte. You don't. It's not helpful.
There was also discussion by Renee about like using the same encoding exactly as others and what the libraries do and so forth. So I don't know if that played the role in that discussion, but
yeah, well, it was encoded as 33 because they wanted to compress it, but there's some use cases required both sides to have the exact same sign representation. So that's what the byte is for. So you can, whether it's plus y or minus y, but if you're throwing away y anyway, then you don't really care what the sign is. And I think you're throwing away y in the PFS draft, right?
John, do you have a comment on that?
I agree with everything Dan says. This single byte is not really useful, but it doesn't really matter so much either. So I personally don't have a strong opinion. I think compliance, most libraries doesn't support this 33 byte either. So to get compliance, you need 64 byte encoding mostly. But yeah. But it's a single byte we're talking about, so it might not be such a big issue. I can live with both personally.
Mohit?
So maybe just thinking of the bigger picture here, EAP aka, and then EAP aka PFS would most likely be used,
2 byte encoding. 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 2 byte e
let's say, more in 3GPP deployments than in other deployments. And if I understood John correctly, the way 3GPP currently uses this curve is with 33 bytes. In that case, we should just follow whatever 3GPP is using, just because it will be like lesser path of resistance for them to hopefully adopt once this becomes an RFC. And I don't know if EAP aka PFS is going to be used in super constrained IoT scenarios where the 1 byte would make a difference. So yeah, that's my feeling.
So if I'm trying to summarize the discussion, just my opinion, of course, but it sounds to be like nobody is objecting to what we actually have now. It also sounds like it's useful maybe for me and John to go through some of the stuff offline, particularly like the references, and that there's no other language anywhere in the draft that would actually speak about some of these things that we were arguing a little bit, but substance seems to be acceptable unless somebody screams now.
Yeah, I think if you guys could go on and kind of make a final decision and update the draft if necessary, and then let us know, and then we can start working group last call, I think.
Yeah, we will report on the list what the conclusion was. So
Awesome.
Thank you.
There's still one more person in the queue.
Nicholas?
Hi, I just had a question about like using 33 bytes. I guess this question is like with the libraries. I guess that introduces some ambiguity because you don't know. Libraries might want to know which Y coordinate they should take, and so that could be an issue. That's all I wanted to say.
So I think the spec will say exactly what to do, and whether that matches the library that you have easily available or not is another question. I think we're discussing that, like what is the right choice here in terms of making that thing easy with the implementations, or that's part of it at least. But the spec will be clear that you have to do that, like this many bytes, and go read here what the format is, and I don't think there's ambiguity after that. There's only ambiguity here, deciding that what should the spec say. But after it says something, I think it should be clear. And if it's not, then we have a problem. But I don't think we do.
Okay, Jonathan.
To build off what Nick said, so it's not an ambiguity. It's just that when most cryptographic libraries, as John pointed out, require 64 bytes. Then you would have to, with a 32-byte representation, you would have to use the curve equation to determine what the Y coordinate is, which would require significant computation, which the library may or may not have.
You have to do those computations with 33 bytes anyway. I mean, the only thing that extra byte tells you is which Y to use. You still have to do the equation of the curve to get Y squared. You take the square root, and now you just decide whether it's plus Y or minus Y based upon the third byte. So you have to do the work anyway, whether you have the 33rd byte or not.
Okay, so I think we still have the same direction for the author and authors to kind of go look at what's available in terms of libraries and other specs and come up with a proposal that we can then run by the group.
All right, thanks.
All right, next we have Alan with TLS EAP types.
Okay, my linked, I look to be linked. I think there's only one slide here. So if we go to the next one, Mohit. Multiple client server implementations, it's allegedly good to go. One issue raised was sort of a throwaway comment in the TTLS RFC that it should be okay to do client authentication using only the client cert and just to skip phase 2. I don't know anyone that's implemented that. It seems a little weird. If you want to use client cert authentication, you should just use ETLS. And the suggestion was to forbid that in TLS 1.3 for both TTLS and PEEP. That doesn't seem controversial, so I think it should be okay. It's already in the last version of the draft I published, and no one seemed to comment too much on the list. The other issue which showed up in the last week or two is a client deciding to not do session resumption for TTLS. The issue with PAP, when you do TTLS plus PAP, there's only one, even half round of information being sent from the supplicant to the server. Here's my password, and the answer is EAP success or EAP failure. We had a bunch of discussion around this. Do we want more to go back so that we have a protected success or failure indicator? The larger issue is that if we send a session ticket instead of EAP success or failure, this implementation decides it's unexpected and treats it as reject. So I would suggest updating the document to suggest that this is not the proper thing to do, and you should continue doing TLS, whatever that means, until you get the EAP success or EAP failure. And this is perhaps a side effect of not having that protected success, protected failure indicator. Other than that, everyone seems to be happy. Implementation seems to be mostly okay. And I think we're good to publish, but I'd like a little more discussion or comment or something around that last issue.
All right, does anybody in attendance have comments about that issue? Mohit?
Maybe not so much on the second issue. I haven't had a closer look at it, but disallowing client cert, I think this should be acceptable. I'm just worried, are we not aware of some niche deployment, and would it make sense for us chairs to send like a heads up that this update of, let's say, TTLS and PEEP, specifically highlighting this RFC numbers 5281, saying that we are basically going to forbid client authentication with client certificate only, in which case you're better off with using TLS. And if you have any implementation or use cases where you are doing that, say now or then don't complain later.
Tim?
Hey, Tim Capelli. macOS lets you configure it via profile. Whether it works or not, I'm not sure.
Yeah, this is Alan again. From what I can tell, the PEEP specs are silent on this issue. So implementations may or may not support this. I know with my server implementation, you can configure this. It's pretty rare so far as I know. For me, I mean, it's one of these things of, it doesn't really break anything to allow this, but I tend to be a little conservative in we already have a client certificate authentication method. If you want to use client certificates only, you should just use that. And so forbidding it in the document, you know, given our experience with various similar forbiddings, doesn't really necessarily affect implementations. but perhaps serves as a warning that this doesn't really make sense. If you want something with a phase 2 authentication, then you should be using the phase 2 authentication. And we really don't know why or what the benefits are, use cases. Therefore, officially speaking, it should be either forbidden or frowned upon. And that exact phrasing is up in the air.
All right, are there any more comments in the room or on the Miteco on this particular issue? If not, I think we want to try to resolve this discussion on the list, and so we can get a new draft spun up and move it forward. So I think we're pretty close on this one.
Yeah, I'll get a new draft out after IETF, and I think we should be good to go.
Okay. Yeah, just Alan, if you could note what the changes are, make sure that we have that so that we can run that by the working group.
I'll do that. Yeah, I'll send summaries to the list.
Great. All right. I believe next we have EAP usability.
There's only one slide here again, not a lot to discuss. I did issue a new update with some minor tweaks and all this. Really what this is this is a way not just to configure EAP, but it's a trade-off in cost. There are possibilities like EAP Fast, TEAP, and some other proposals later in this meeting where you use EAP almost as a general transport protocol to transport all kinds of provisioning information. And there's provisions for queries, and TEAP has provisions for requesting client certificates and pushing all kinds of information back and forth. And speaking as an EAP implementer and someone deploying and supporting these things, it gets complicated. It's certainly easy in some respects for administrators who support this, just to click a button saying allow provisioning. But it makes the EAP implementations more fragile. The error messages that show up to the user tend to be opaque if they exist. And this proposal pushes the EAP configuration complexity off onto standard internet protocols, followed by a OS specific configuration tool, which just does whatever it has to using private APIs or whatever you want. So there is a little bit more work for site administrators to set this up. But the nice thing is once it's set up, you really don't care what else is going on in your network. It's independent of EAP type, et cetera, et cetera. So we do have buy-in from a bunch of people to move forward with this, implement this. So the question is, what does the larger working group think?
Elliot?
Hey, good afternoon to those in the room. Good morning to people who aren't in the room and elsewhere in the US. Alan, thanks for this draft. I looked this over a long time ago. There were a couple of issues that I'd seen back then. But I just wanted to address one point here first, which is my focus is really, as you guys know, on IoT, where you don't have user interfaces. You need standard interfaces to run things. And one of the standard interfaces we need is a way to get a certificate. So, and not just a certificate, but a trust anchor, right? So the exact things that you were talking about in TEAP are the exact things that an IoT device needs. And you are suggesting that these be taken using standard internet mechanisms, I'm presuming you're referring out to stuff like EST or ACME or some such. Can you elaborate a little bit more on where you think you're going there?
Yeah, the standard internet tools here really are not it. Sorry, the intention here is not so much for IoT, where you have a device with no UI, no network connection, looking to bootstrap. That's a complicated thing, and you definitely need something specific there. And yeah, that really does have to look a lot like EAP. Generally speaking, for other devices, you know, my phone, for example, pretty much always has two network connections, Wi-Fi and a backhaul on 4G, 5G, whatever. My laptop, for example, I can always walk down to Starbucks and get a completely unauthenticated internet connection. When you do that, you have DNS, HTTPS, ACME, EST, whatever, that will almost always already be on the device and already have software there. And so the use case I really envision is, you know, someone starting at a new company and you get told, yeah, here's the standard DNS names for all of our configuration. All the certificates, et cetera, are available on HTTPS. Go and do that. The issue for me is loading all of this into EAP is very, very complicated. And when it works, it's absolutely fantastic. And when it doesn't work, the user and the administrator generally get messages like failed. And it could be one of 16 different things which fails, and they have absolutely no idea.
Yeah. Sorry.
Okay, Bernard.
Hello. Yeah, so I generally agree with where Alan is going with this, you know, absent some considerations for IoT, because as was said in the original applicability statement, EAP is not really good at transferring large amounts of data, which would include the configuration. And that's why it's probably a better approach, if you can do it, to just get on the network and then download the stuff using, you know, a full TCP/IP stack. And the configuration, I don't know how big it is, Alan, but it can be complicated. So as you said, it's a lot less fragile to do it the way Alan's recommending.
Yeah, just to respond to that, I mean, it's certificate chains. In the worst case, I've seen, you know, 64K of data, and then people complain that they can't get that down an EAP session.
Right. Yeah. In particular, yeah, those are where you get the failures, because you're sending a lot of data. You know, you get into all the issues that we got into, you know, recently with ETLS trying to shorten the certificate sizes because of those exact same failures. So yeah, you're right. You're going to dramatically improve the likelihood that configuration will succeed.
I think Elliot is still in the queue. Elliot, please go ahead.
Thanks. I mean, my thinking is we should. I understand Alan's use case, and we sort of have two directions we can take. Direction number one is, Alan, you just scope the document in terms of these are the use cases I'm trying to solve, and these are the use cases that may not be applicable for this document. That's one approach. Another approach would be that we see if we can ponder the model that we really want that covers them both. And sometimes that's reasonable and sometimes it's not. Right? The issues that you're talking about in terms of data transfer sizes, there's probably timeouts involved. as well that come into play in some of these cases. The link path issues relating to what's running underneath. There are a myriad of problems that EAP can run into. But and it's nice to keep EAP nice and thin. On the other hand, when we push these things into other layers, the complexity isn't just in one place. It spreads into L3, for instance, where you have trusted, untrusted mechanisms that end up getting into place, especially with the IoT case. We see this in some of the deployments we have. And we'd like to get away from that, because that complexity leads to other problems. So one challenge I think we face then is, and it really, to me, all this boils down to is, what do you do with TEEP and things like TEEP? How do we make it, what is the right approach to get trust anchors and certs and such into a device without having to apply a whole lot of layer 3 complexity? Because that complexity hurts too. It can also be difficult for administrators to handle. It adds its own fragility. So I'm not saying let's not do this draft. Don't get me wrong. I'm just saying that we should think about how we want to tackle, whether we want to tackle these problems together or apart. And it may make sense to tackle them apart because you can at least reduce the pain for some group. And you're right, Alan, that there are a number of devices that already have some form of connectivity, and maybe there's some relief here for them. The other thing that we have to think about in terms of that relief is it also may open up attack surfaces that we want to think about too. Specifically, do we really want, the moment you say, okay, let's have an EST server or something like that to handle certificates, you end up thinking about how you have to harden the EST server to client requests. And if you can put something in between that is already doing some sort of policing, that has its own value. So I'm just saying it's a bit of a mire, and I'm sure, Alan, that in terms of what you're doing, you're living this nightmare. So I don't want to understate the problem that you're trying to address. I think it's a legitimate problem. Anyway, I'm sorry for talking so long.
Yeah, Tim.
Yeah, Tim Capelli, Microsoft. Alan, super in favor of this. It's frustrating, even just to connect here. It took me 5 minutes for a IETF. It may make sense, in my opinion, to scope this to user-centric devices and flows, right? I think scoping it down to the non-IoT use case makes it much easier for a consumer of the spec. And I think, in theory, when some of the work Dan's doing and others are doing on IoT, that could become a parallel document that covers IoT. I do think they're discrete, they can share, but I think ultimately it's 2022 and people still can't get on a network in under 30 seconds with their phone or their laptop. So to me, that should be a very, I don't think you have to change much of the doc. Maybe it's just the scoping and the intro and even the name potentially.
What I'd like to do with this particular thing is not go for an adoption call right now, but have a little bit more discussion on the list on the scoping, because I think that would be, appropriate to make sure we have the right scope. So I think that's what we should do. So take it to the list. All right, Alan.
Yes, looks good to me.
Yeah. Next, I think we have Dan and DPP. Is it? Yeah.
Okay, thank you. Next slide. My name's Dan Harkins, and Owen Friel and I have been working on this idea of using the device provisioning protocol, which is it's a Wi-Fi protocol that solves the onboarding catch-22, where you need a credential to get on the network, but you need to get on the network to get a credential. It's basically the problem everyone's been talking about. And it does this by gaining trust in what it calls a bootstrapping key, and then it uses this trusted public key to authenticate the device and provision it. So we want to leverage that same sort of DPP bootstrapping key, but use it with EAP. So the way we do this is we glom onto TLS authentication using RC 8773 that defines an external PSK, which we derive from the trusted bootstrapping key. And then we do 7250 TLS authentication with raw public key, so the client can prove possession of the corresponding private key that corresponds to the public bootstrapping key. And then we have to signal that we're doing this using the extensible PSK's draft. So next slide, please. So this is the classic TLS authentication exchange. And the normal font is just normal TLS. The boldface stuff is what's added for DPP, and the red boldface is the new stuff. So all we're adding that's new is signaling this bootstrapping key ID. Other than that, it's the same 8773 and 7250 external PSK and raw public key authentication. So next slide, please. So how this all fits into EAP then is we want to do this with TEAP. So what happens is identity response, the supplicant just says, TLS poke or whatever to signal that it wants to do this sort of authentication. And then the TEAP exchange gets authenticated with what I just showed you in the previous slide. And once TEAP has been authenticated, we can use the PKCS 10.7 exchange that's already in TEAP to provision a certificate on the supplicant. And then the supplicant's subsequent connection will be using classic EAP TLS with the cert. So next slide, please. So the drafts in 04 didn't really change much from 03, just some minor editorial changes. We do have running code, and we're looking to get rough consensus.
Okay. If there are Mohit and Bernard, well, Mohit first.
Just very quick comment about the 8773. I think I like that RFC, and thanks for us for the work. But it was labeled as experimental, and at that time there were not many libraries supporting it. So I wonder if that status has changed now.
I'm unaware of the status of that.
Well, this is still experimental, but you've just heard about one implementation that may be enough to advance.
That was Russ.
I'm sorry, Russ, I didn't catch what you said.
But it's still experimental. Based on your implementation, we may be able to move it. Ask the guy next to you.
Said it's still experimental, but we may be able.
Oh, okay.
I think Russ, you broke up a little bit. It's still experimental, but we may be able to move it beyond experimental based on this use case. Okay.
Well, you, as the TLS working group chair, have to call that one.
Yeah. Well.
Put on a different hat, Joe.
We'll have to discuss that in a TLS context. But yeah. Bernard.
One thing you mentioned, Dan, is the use of an identity response in a way that's actually fairly common, but has never really been standardized. So very often in these kind of initial contexts, you want to get the server, you want to tell the server you want to do something like you use anonymous or use TLS poke or something else with the intention of eliciting a certain response from the server. We've never really documented these things. And it might be a good idea to do it so that at least we get some standardization. But
Okay.
I've seen that run quite often. I don't know if Alan can comment.
That is a good suggestion. Thank you.
Oh yeah.
Yeah, I'd like to see this draft move forward. It has the benefit of essentially providing an analog function to what's already available in the Wi-Fi Alliance for the wired system, and it looks like a pretty elegant solution actually. And I do think one question that comes up is, once this work is well enough along, right, we probably need to do, dust off the TEEP update and get that going again. It can be a lot more narrowly scoped than earlier attempts, though. The good news there is that we've seen a number of the errata verified already, thanks to a couple of people working on that, Yoni and Roman, who did the verification the last time around, and Oleg Pekar. The only reason I say we need to open up TEEP is I think probably we want TEEP to, or maybe a rev of TEEP to reference this work. If we don't move this forward, though, we end up with a chicken and egg problem. And so I'd really like this to move forward.
Yeah, one regarding TEEP and referencing that. Can you go back one slide, Mohit, please? So one thing that I kind of slyly avoided was the CSR attributes TLV doesn't really exist in TEEP yet. And I think it really should. Yeah, I think a TEEP update draft needs to happen, and when we add CSR attributes, then we can reference this draft as well.
Okay, I think there's maybe some things to resolve with TLS. I don't know if I'll have to talk with you and talk with other chairs and see if that's a blocking thing for this or not. I don't think it is. If it's not, I would like to do an adoption call. I think for this, because it seems like there's a couple people have gotten up and expressed interest in. So does that sound reasonable, Mohit?
Yeah, I joined the queue again. So I am for adopting this. The reason I joined the queue was basically as you as the TLS chair as well. It doesn't have to happen before adoption. It can be after adoption to get some like TLS eyeballs on this, because I could be wrong since I haven't read it in a while and I couldn't follow the slide so closely, but 8773 is basically combining certificate-based authentication with external PSK. But what this draft is doing is combining external PSKs with raw public keys. There shouldn't be any issues with that, but it would be good to have like more TLS eyeballs on this, and that can happen after adoption. I don't know if that would be a blocker, but as the co-chair of TLS, Joe, if you could I don't know, reach out to the right people to have a look at this.
So actually, what our previous way to do this didn't use 8773. What we did was we generated a new elliptic curve point using the bootstrapping key and injected that into the TLS key schedule. And when we brought that to TLS, both Watson Ladd and Eric Rescorla said that it was complicated and it required, a lot of heavy lifting to pry that into TLS, and it was easier and better to use 8773 and 7250. So it was actually the mandarins and the TLS working group that suggested doing this in the first place.
Yeah. Okay, I think I think we need to move to the next presentation. So
okay. Thank you.
Yep. Okay, next I think we have Mei Ling and EAP IBS.
Hello.
Hello.
Okay. Hi, everyone. I'm Mei Ling Chen from China Bio. I would like a quick introduction for my draft IETF IBS again. Next slide, 6. We should be most concerned about use cases. Currently, Conside 2.1 is used for IoT authentication, and the other is distance that not support X509 certificate. The goal is to improve the authentication efficiency. As for the code, we have implemented the prototype in 2020 for our internal Internet of Things system. So far, we have received some comments both online and offline as I list on the site. Thanks to Ross and Xin again. Next slide, thanks. This is a simple example ECCSI used for IETF IBS. The most important thing is the use of extensions server certificate type and the client certificate type, which first defined in RFC 7250 to support raw public key and signature algorithm, which defined in RFC 8446 but new added in IETF method for signature selection in my draft. And we wrote it. Identify base signature contents in the certificate and certificate verify fields. Using IBS-based raw public key in IPTLS does not change the message for rows. Next slide, thanks. People who have not read RFC 6507 in detail may not exactly understand how the verification is completed in this example. So on this page, I outlined the whole process. Prerequisite parameters are sent to client, and the client procedures for verification is more detailed here. Then the draft finally successful signature verification means that this identity has been verified. Next slide. For this presentation, I took a picture for the ECCSI, the procedure of initialization, signature, and signature verification is very clear in this procedure. It is worth noting that ECCSI is only one algorithm of IBS. Mixed usage raw public keys and X509 certificates, it can also be used here. You only need to specify the corresponding certificate type, such as the client used the ECCSI key for client authentication, and the server provides an X509 certificate for server authentication. We hope this will become a workgroup item. Thanks. Any comments?
Just maybe for the benefit of those who haven't read or followed this, if I'm not wrong, at least this draft requests a separate method type and doesn't use the same method type number for standard ETLS 1.3. So it would be a separate EAP method number.
Thanks, Mohit, but I think not get your questions exactly. Can you speak slowly for me again? Thanks.
Sure, there was actually no question. I was just stating for
Okay, thanks.
benefit of the audience that this will be a separate method number, but maybe now it's time, Joe, if you want to check, get a sense of the room.
I'm going to use the show of hands tool. And so if you've logged in like you should have into the room thing, you should be able to respond to this thing. What I'd like to know is if people have read this draft or not. Okay, so we have, I'm gonna end it in 5, 4, 3, 2, 1. So I think, does it show the result somewhere? It looked to me like there were about 8 people that had read this draft, so there's at least some folks that have read it. What
Yes,
I
there were
think
29 participants, 21 did not raise hand and 8 raised hand. So just for the minute taker.
Okay. And then what I'd like to do is maybe, I think we should have a call on the list. Since we have people who have read it, I think there's some interest. Does that sound reasonable? To take this to the list, do an adoption call?
I guess, is there anyone who in the room or online who thinks that we should not adopt this?
Yeah, would there be any objection to adopting it that people would want to raise now?
Yes, I think so. Maybe we can try adoption for this draft because I think this way will push more people to pay attention to this method and IEBS. I think there are many people can help.
Yeah, so I think we'll take this to the list.
Okay, thank you.
All right, next we have, I think, Jan with not much time. I'm sorry.
Yeah, it's okay. I'll try to rush through it. Yeah, my name is Jan. I'm currently for a master's project looking into IPNOOP. And as part of my work at the German Research and Education Network, I'm also in the EduRoam team. So I found this very interesting, and I have read the draft and tried to implement it. And while implementing it, I have noticed some things about IPNOOP that I just written in this observations draft. Could you move to the next slide, please? So the first observation that I made that kind of puzzled me a little bit is why use JSON as the payload encoding. I've seen some communication on the mailing list why this was chosen, but I had some problems with implementing it because of the canonicalization problems with the JSON, especially for the Mac and hoop calculation. The status of the server info and peer info was kind of ambiguous for me because there are some different specifications throughout the draft. Maybe I read the draft wrong, maybe not, I'm not exactly sure. Next slide, please. And the number of messages exchanged seemed to be a little bit on the high side. So especially the initial communication where the first message has no information at all and the second message is just for communicating the peer ID and the peer state. And one small editorial note, I'm quite new to the IETF, so I don't know if this justifies an errata. The version is never explicitly set to this is version 1, there are just example values given. Coming from that, but also noticing that the method itself is very good and I actually like the design principle. I've come up with a new specification, IPUTE, User-Assisted Trust Establishment. If you can move to the next slide, which basically uses the exact same design principles as IPNOOP does, because they are actually quite good from my point of view. But IPUTE uses CBOR as payload encoding. I've seen that this was already a discussion item on the lists and was on the agenda for possible version 2 of IPNOOP. CBOR has some advantages over JSON. For example, I can have the exact byte strings and don't need to encode them with base 64. And for using integers instead of strings as map keys, I have shorter messages. And my current specification uses a map calculation over the whole message. So the communication partners do not really need to understand the complete message or all protocol fields, because that would possibly break extensibility. We can move to the next slide. So for the 00 version of this draft, this is a very early draft version. I don't know if anyone has read it yet. This is part of my master's project, so I will develop it further in the next months. I have already made some modifications. I'm not exactly sure if I already pushed them to the GitHub repo. And I have some completely open questions. For example, how will I specify the cipher suites? My idea was to piggyback on an existing registry, for example, the COSI elliptic curves registry. But then I have the problem with what hash function will I use? So these are some of the open questions right now. And for now, my question to this working group would be, is this something that I should continue to work on? Is there interest here?
Okay, I don't think we have time for questions, but certainly feel free to contact Jan, and there could also be some discussion on the list on this as well. So I'm going to move to next presentation, which I think is Max.
While I open the last presentation, just Jan, I'm obviously interested in the work, so we can continue the discussion on the list. But I don't think it's Max presenting, it's Yuan.
Yeah.
So,
Okay, Yuan.
Yeah.
Yes, it's Yuan. So thank you guys. I'm glad that I still have time to present my slides. And I also saw Max join in the chat, so feel free to chime in, Max, if you want to leave any comments or answer other people's questions. So today's my presentation is about the IPCRESS overview, and this is a method, well, an IP method that's used for secure the access network's credential management. Next slide, please. Thank you. Yeah. So while we are working on defining the architecture and also the spec language of the access network, and we find that automated credential management is a very important issue, as it may cause user data privacy risks and also the theft of services if misconfigured. And meanwhile, in a typical access network, there are different types of the credentials that need to be provisioned and also managed, and that includes the user level credentials, network, and also device levels credentials. And those credentials tend to be forgotten and remain to be managed for quite long times due to the possible operational and also administrative difficulties or the costs. And meanwhile, today's credentials management also requires active configuration, such as the IP address provisioning of the devices and also the service endpoints. So, because we noticed those, the features and challenges of the automated credential management in the access network, we propose the IPCRESS as a method. And currently, the IPCRESS protocol supports different types of access networks already, and that includes the WAN network, which is the DOCSIS with VPI+, and also the Wi-Fi network and also the 3GPP network. And meanwhile, already defined the IPCRESS with the simple provisioning protocol for the CBRSA network, and the documentation's number is TS1003. Next slide, please. Thank you. Yeah, and here you can see this is just offer you an example of where the security is provided. So between the IP client and also the authenticator, we will rely on the max security that could be the NAS in 3GPP or the BPI+ in DOCSIS. And meanwhile, between the authenticator and also the IP server, we will rely on the application layer security, and that could be the TLS and other types of VPN protocols. Next slide, please. Yeah, and to just give a quick overview of the IPCRESS. So the IPCRESS just provides a non-IP-based mechanism to subpromatical protocols credential management, and it will offer the active management and also configuration of the device or the network layer credentials. And meanwhile, we try to keep the IPCRAS message flow to be simple. And like I said, IPCRAS will just rely on the security of the external communication channels for confidentiality. And basically in the IPCRAS protocol, we define 3 phases. The first phase is the initialization phases, where both entities will exchange the credential configuration and also the information, and also the supported version and the protocols. And in the provisioning phase, both the server and the client will execute the encapsulated protocol, such as the simple provisioning protocol, for example. And the last phase is for the validation, where the server will validate the ability for the clients to correctly use the credentials before the server claims this is a success of the IPCRAS. Next slide, please. Thank you. Yeah, and this diagram just simply offers you how the message flow between well in the 3GPP network cases and also the wild and also the wild network. And at the above of the IPCRAS, that will be the protocol that is encapsulated in the IPCRAS payload. So in the first cases of the 3GPP network, that will be the SPP messages, for example, and also in the second case, that will be the CMP messages, for example. And next slide, please. So the next slide just tells you that, yeah, so this slide will just tells you that how the IPCRAS encapsulate and also decapsulate the messages. So IPCRAS is IP-based, so which means that the IP abstraction layer is the base of the IPCRAS. And meanwhile, the IPCRAS server will terminate the IPCRAS messages and decapsulate the payloads of the IPCRAS, and then forward the content of the encapsulated protocol to the corresponding provisioning protocols endpoints. And next slide, please. Thank you. So the current status of the IPCRAS is that we already have the IPCRAS core internet draft available at this link. And our key focus now is try to offer a separate and independent ID draft, which is the IPCRAS SPP ID draft. And this new ID will just describe how the SPP is used with the IPCRAS protocol. And this can be used as a template for supporting other protocols encapsulation with IPCRAS, for example, the certificate management protocol. And so our goal is to have the initial drafts ready for review and comments. And then we will plan to resume our activities within the working group. And hopefully we can just, continue our discussion and with, working group at the next coming meeting. And we are also currently looking for the collaborations and contributions. So if you are interested or if you would like to offer your points or comments or ask any questions, please feel free to reach out to us. And thank you. And that's all for the IPCRAS presentation. Thanks.
Okay. I think we're just a bit over time, so thank you all for attending. Thanks for the presentations, everyone. Sorry, next time we'll try to get our meeting times a little bit more in line with the number of presentations. And we hope to see you either online or in person at the next IETF. And we're looking forward to everybody's participation on the list. Thanks.
Thanks, Joe. Thanks, everyone. Bye.